Okay, good morning. Welcome to
SuperMath number 50.
SuperMath number 50. So today we were in the section about Pythagorean triples in our book. And we were looking at some patterns with different triangles. And we wrote down a list of triangles like this. 3, 4, 5, 5, 12, 13, 7, 24, 25. And what are some things you can tell me about the pattern here?
Well, this bottom side seems to be even.
Okay.
And then this side here seems to be odd, this short side.
Okay.
And these differ by 1. This 5 and this 4, this 13, this 12, 25, and 24.
Oh, okay. So how could you describe that differing by 1 in words, using like language about triangles?
So 4 plus 1 is 5.
Well, using language about triangles, how would you describe that pattern using language about right triangles?
So the long side is 1 less than the hypotenuse.
Very good. Very good. And so we started wondering, how does this pattern continue? What's the next one? The short side on the next one's going to be what?
Well, I think the short side will be 9.
9.
Any other patterns?
Yeah. Any other patterns?
Well, 4 plus 8 is 12.
Okay.
12 plus 12 is 24. So, I think, I'm not sure.
Okay.
Well, we need another pair like this.
Yeah, we need another pair that differs by 1, so we're going to have to solve this equation. 9 squared plus x squared equals what?
Equals the hypotenuse squared. So, y, we can call the hypotenuse y.
Okay, we could call the hypotenuse y. Is that the best representation for this problem?
No, it's x plus 1 squared.
Okay. So we notice we're looking for ones that differ by 1, and we're wondering, is there a solution with 9? So we have 9 squared plus x squared equals x plus 1 squared.
So, well, 9 squared plus x squared, we can multiply this out.
Alright.
It's going to be x squared plus 2x plus 1. And then the x squared subtract away. So I get 9 squared is 2x plus 1.
No, I don't know why I keep writing 9 squared. 81 equals 2x plus 1.
So 2x is 80, x is 40.
40, so we get 40 and 41. But there was an interesting thing right here that I don't want to skip over. That 2x plus 1. Now remember, x is the short side?
Yeah.
Or the
longer leg.
The long leg, the short one between the hypotenuse and the side. It says 9 squared equals 2x plus 1. So twice this plus 1 was this squared. What about here?
Well, let's see. Twice that is 48, plus 1 is 49. So that works. So twice that is 24, plus 1 is 25. That is 5 squared. That's going to be 9 equals 3 squared.
Okay. So can you tell me from that what the triangle is going to be with 11?
So it'll be 11 squared is 121, minus 1 is going to be 120. So we get 11, 60, 61.
61. And we can check very quickly if this is true. With some arithmetic. How can we check, does 11 squared plus 60 squared equal 61 squared? Okay. Without multiplying it all out.
Well,
What could we do?
This is going to be pretty tough to multiply out.
Yeah, right. That's why I'm trying to avoid multiplying it out.
Well, I know 6 squared is 36.
That's multiplying it out
Yeah.
there. Try to find a clever thing that doesn't involve multiplying out the squares.
So what about if we use the difference of squares?
Okay. How's that gonna work?
So, I think, but we should use this on this side. We should move the 60 to the other side. Though we can't because we don't know if it equals yet. So I'll just do it here.
Okay.
We have 11 plus 60 times 11 minus 60. Except it doesn't look like it would work.
What do you have on this side?
We have an 11 squared and a 60 squared.
Okay.
And the difference of squares says 11 plus 60 times 11 minus 60
Equals what?
equals 61 squared. We just made this side a little different.
What does difference of squares say? That 11 plus 60 times 11 minus 60 equals?
It equals this. It should equal that anyway.
Multiply out.
This.
Sure.
So it's 71 times negative 49.
Okay. So do you think 71 times minus 49 equals 11 squared plus 60
No.
squared? But you told me it did.
Well, it didn't work out to work.
Why not?
Because 60 is the larger of the two. So you have to put the larger one first. But even then you get 71. You get 71 times plus 49.
What happens? What is the formula you're using here?
Well, x, for the difference of squares, it's x squared. It has to be x squared minus y squared.
What do you have there?
X squared plus y squared.
Okay, so can I use a difference of squares here?
Nope.
No. Okay. What do I need to do?
You need to move the 60 to the other side.
Okay. Can I do that?
Well, you can't since we don't know if it's equal or not.
All right, but how could I do that? What can I do?
Well, you can't move anything around to the other side since we don't know if it's equal or not.
It's interesting. That's an interesting hypothesis. What do I do when I move that 60 squared to the other side? What am I doing?
You're subtracting 60 squared, and you're subtracting 60 squared here.
Okay. All right, now is that an okay thing to do?
Well, yeah, you're doing the same thing to both sides of our equation.
Okay, so now you were confused about that. I don't know if these two things are equal, right?
Yeah.
Now I do the same thing to both sides.
It still preserves what you have.
Okay? If they're not equal, if I do the same thing to both sides, subtracting, what's going to happen?
Then it's still going to be not equal.
And what if they're equal?
Then it's going to be equal.
Okay, so what do I have now?
Now you have 11 squared is 61 squared minus 60 squared.
Okay.
Now we can do a difference of squares. 11 squared is 61 plus 60 times 61 minus 60. So this is 1, so we're timesing by 1. And 61 plus 60, 11 squared does equal 121 times 1.
There you go. Good. Good struggling through that. Okay. The difference of squares can't apply to plus. Okay, it's got to be a difference. Move it over to the other side. That's an okay thing to do because you're doing the same, subtracting or adding the same thing to both sides of an equation is okay. And then it all works out. All right. Good job, man.